Hello, it is Mr. Wynn with a lesson on the surface area of cylinders. I'm going to try to make this short and sweet so that you're able to understand it easily. So, like I said, we're learning about the surface area of cylinders. And the focus of this lesson is to understand what surface area is, to see the formula for the surface area of a cylinder, and to understand why that formula looks the way it looks. We're actually not going to use the formula today yet, but we're going to understand why it is the way it is. So, first and foremost, we're going to start off with a cylinder. Okay. And a cylinder is actually made out of two other shapes. You have a circle and you have a rectangle. We know that the area for a circle is pi r squared. And we know the area of a rectangle is width times height. Width times height. By the way, this r, that represents the radius, which is the distance between the center of the circle to the outside. So usually you're given that. Pi, you know what pi is. So it's pi times r squared, which is different than r times 2. This is r squared, r raised to the second power is another way of saying it. So here's the formula for a circle, for the area of a circle, the formula for the area of a rectangle. Now the formula for the surface area of a cylinder, which you haven't learned yet, is going to be 2 pi r squared plus 2r pi times height. When there's no sign in between numbers and letters and whatnot, that just means multiplication. So usually for a problem with a cylinder, you're going to be given the radius and you're going to be given the height. And as you can see, that's what you're going to have to plug into this formula. 2 pi r squared, r right there, plus 2r again, pi h. And remember, pi is just a symbol that represents 3.14, which you can find on your calculator. So how in the world did people figure out that this is the formula for the surface area of a cylinder? Well, if we look at a cylinder, I'm going to redraw it right here. So I'm going to get the a better camera very soon once Mr. Land contacts me, and it's going to be much more steady, so please bear with me. So you have a cylinder, right? Now, if you flatten out the cylinder, if this was, for example, like a cardboard box, but a cardboard cylinder, right? If you flatten it out, you get this. So if you flatten out a cylinder, you're going to get this right here. And this is called a net, by the way. Anytime you flatten out a 3D shape into its 2D components, this is called a net. So going from here to here, this is called a net. And you're going to see that word, a net. Okay. Now let's start breaking it down. So we know that the total surface area of the cylinder, by the way, just a reminder, surface area is different than volume. Volume is if I were to fill up the cylinder with water. That's what your volume would be. Surface area is if I were to paint the outside of this cylinder. Every part of the cylinder. Pretend this was a white cylinder. I wanted it to be a red cylinder. Me painting the whole thing red would be its surface area. Okay? Volume is filling up this cylinder with water, as if it were a water cup or something. Anyways, back to this. We have this cylinder and we have its net. You can find its total surface area by finding the area of its components and adding them up. And as you can see, the components of this cylinder is a circle, another circle, and a rectangle. Now we know that let's label some stuff. Usually you'll have a radius, you'll have a height, and you're gonna need the width of this rectangle, but they're not gonna give it to you, but I'm gonna put that there here. I'll put it in a little cloud, which means you need it, but they're not gonna give it to you. So, anyways, to find the area of the components, so the area of this circle would be pi r squared, as we saw over here. The area of this circle is also pi r squared. And the area of this rectangle is width times height. But like I said, they're not going to give you this width. And the way you're going to actually have to find out what the width is with what they do give you is, well, I'm not going to just tell you it. I am going to tell you it, but I'm going to give you the explanation why it is what it is. So you see this circle right here? If you were to like flatten it out, like pretend I ripped this circle and then like it was a piece of string, right? And I ripped it and then I made the string a line, then that string would be the exact same distance of this line right here. It would be the same length as what the width is. So because they don't give you width, you can actually find the distance of the outside of this circle and use that as width. And the distance of the outside of a circle is something called circumference, if you remember. And the formula for the circumference of a circle is 2r pi, which is different than pi r squared, okay? So that's the circumference of that circle, which is equal to the width. So 2r pi actually equals width. So instead of doing width times height, you're going to do 2r pi, which is the same thing as width, as you can see right here, times height. So I know what the area of this circle is. I know what the area of this circle is because it's the same. And I know the area of this rectangle. If I add them all up, if I add this circle with this circle, pi r squared plus pi r squared, that's going to be 2 pi r squared. And then I'm going to add the area of this rectangle, which we know is 2r pi times h, 2r pi times height. And as you can see, this formula right here is the same as the formula from up here, which is what I gave you initially. So initially I just gave it to you. Now I explain to you why it is what it is, okay? And that is all for now. This is the same as that. And I'm going to post this paper. I'm going to scan this and post this, and you can look at it for reference.